Hello, everyone. Welcome again to Pharmaceutical Calculations with Dr. Dave. This video lesson is going to be talking about some calculations that are involved in veterinary medicine, so veterinary prescriptions that you might see. Also, looking a little bit more at some compounded type of calculations that we see in compounding formulas, as well as converting between salts and bases of certain drugs. So let's first look at an activity that you kind of got introduced to in your active learning exercise about calculating a dose for veterinary medicine. So this one is going to be an example of certain directions on SIGs that you might see in a prescription from a vet. They use one abbreviation, which is SID, which in their Latin abbreviations means once a day. So if you do see SID, which I have seen, some people thought it was 5 times a day. It is not. It's their way of saying once a day. So all the calculations are the exact same. We're just talking about a different patient. In this case, is a pet or another animal. So this is said, what will be the dose and directions of use for the following prescription? So if we see the animal is 15-pound dog, and it says a 0.5 milligrams per kilogram. Same thing we always do in patients. With humans, we take the 15 and we divide it by 2.2, and we get our pounds, maybe 6.818 kgs. It's the patient's weight. So this is what their weight is. The next thing we're going to do now is find the dose. The dose is 0.5 milligrams per kilogram, right? 1 kilogram. And they weigh 6.818 kgs, and you should get about 3.409, which we are going to estimate about 3.4 milligrams. So that's the dose that you would give. So furosemide would be dosed at 3.4 milligrams. A lot of times you might see liquids for vet purposes, for veterinary products, as well as you can compound a product that has 3.4 milligrams in it, because you're not going to find that commercially at all. Here's another example. This is a bird, a little cockatiel. They have 6 milligrams of ketamine that's going to be dosed to them intramuscularly, and they were using this for anesthesia. And like I asked in the example, it was asking you, like, what would you write down in the chart? So can you convert this into a milligram per kilogram basis? So it's an 85-gram cockatiel, was administered 6 milligrams of ketamine. What is that in terms of milligrams per kilogram? So if the bird had to come in again, or there was another cockatiel that you wanted to match the same dosing that you used for that anesthesia, what would you mark down, or what would be in the chart for the amount that was used? So we know that we used 6 milligrams, and this was for a 85-gram cockatiel. So if we were to do that into kilograms, I'm going to directly convert that into kilograms, right? By move the decimal point over 3 places. So this is the amount of milligrams per kilogram. So when I divide that out of my calculator, I'm going to get about 70.588, or roughly about 70.6 milligrams per kilogram. So that's what I would write into my chart, that it was about 70.6 milligrams per kilogram. The next example is one that we have seen before. And again, it's just a change in who the patient is. So this is for a canine. So it's a dog who we're trying to improve their oral health, and this is a chlorhexidine gluconate solution. And we are looking to make a 0.12 chlorhexidine gluconate solution. Right? So let's say we weren't able to get it commercially. How can we make this, right, if we have a bottle of 2% chlorhexidine gluconate, right? So it says how many mLs of this. So I basically have an empty bottle that I want to make at 0.12%. I have a really concentrated small bottle. This one is, I think, what did I do? 2% chlorhexidine gluconate. So this is 2%. The question is asking us, how much of this do I have to put in here, and then QS it with water to 1 pint, right? So how much of this 2% do I need to add? That's the concentrated, so that when I dilute it up to 1 pint, it becomes 0.12%. And then this is going to be used twice a day to clean the canine's teeth. So good old concentration 1, volume 1, concentration 2, volume 2. How do I know that? I've got a concentration, right? And I know the amount that I need, and I have another concentration, and I'm looking for an amount I need. Concentration, volume, concentration, volume. So if I take the first one, I want to make a 12% or 0.12% concentration, and the amount that I want is 473 mLs. How did I know that it's 473 mLs? I converted 1 pint to 473 right off the top of my head. It is a immediate conversion you can utilize. I'm keeping these concentrations in the units of percent, so I'm not converting percents to decimals, just keeping it in percents. You can convert them into decimals if it's more easier for you. The concentration of the one that I have is 2%. Right? I should actually put the percent sign there. It's 2%. So as long as the units match on both sides, you're fine. So I'm just keeping them in the units of percent. It's fine. The question is asking me, how much do we need of this one? So what's this V2? What is that going to be? When I do that out in my calculator, so V2 should be equal to about 28.38 mLs. Meaning that I'm going to now take from this product here, I'm going to take the 28, I'm going to take the 28 mLs out of here. So 28 mLs is going to go out of here. So I'm going to fill up 28 mLs here. Then I'm going to QS the rest of it with water all the way up to the 473 mL mark. And that will give me a 12.12% solution of chlorhexidine gluconate. All right. The next things that we're looking at is in reference to compounded preparation. So these are looking at those types of products that we compound with, and you'll get a little bit more of this in compounding lab. But the initial calculations is something that we're going to discuss here to get us prepared for that. So a lot of times when you see formulations, these are called master formulation records. You can look at them as a recipe. So if your recipe is for making cookies and the recipe is for 12 cookies and you want to make 24 cookies because you got more people coming over, what do you do to the formula? You just basically double everything, right? So instead of 2 eggs, you use 4 eggs. Instead of 2 cups of flour, you use 4 cups of flour. Well, we do the same thing in compounding. So we usually have a formula, which you can call it a recipe, but it's called a formula or master formulation record. So that formula is the directions of how to make something. And usually it's in standard amounts. So usually it's like out of 100 or 100 mLs or grams. So it's a nice number to use. But we usually don't dispense always 100, just like we don't always make 12 cookies. So sometimes we have to convert it to just make either, let's say, 30 capsules or to make 12 suppositories, etc. Sometimes they're even larger. Sometimes they're out of even 1,000 mLs or 1 kilogram for larger recipes and formulations that we have. So let's look at this. It says, based on the following compounded formulation. So this is, again, a formulation is just being looked at as like a recipe, which is what this is. Determine the quantity of each ingredient that we would need to prepare 15 mLs of the ophthalmic solution. So this is a formula for an ophthalmic solution. It says, let's look at each one of these. We have erythromycin. This is the API, the active pharmaceutical ingredient. It's the drug. We have another drug, which is dextromethorphan. So this is something for a steroid for inflammation, typically. The erythromycin is our antibiotic. We're going to be using glycerin. And then we also are going to add, after we mix those 3 ingredients, we're going to QS with sterile water up to 100 mLs. Now the question is that we only want to make 15 mLs, but this formula is for 100 mLs. How do I know it's for 100 mLs? The last ingredient says AD, or you might see QSAD. It means a sufficient quantity of 100 mLs. So you add everything up to 100 mLs. So this formula is for 100 mLs. We only want to make 15 mLs. All we're doing here is just doing ratios, right, and proportions. You can do it by dimensional analysis. You can do it other ways that the book will also show you. Let me give you an example of the first way. So erythromycin lactobionate, we know that it's saying that this has 500 milligrams every time we make 100 mLs. Well, if we're only going to make 30 mLs, how much do I need? Or sorry, 15 mLs, I apologize. We're only going to make 15 mLs right here. So we're only going to make 15 mLs, that would be 75 milligrams. Right? I can also do the dexamethasone. So the dexamethasone is 100 milligrams, as we see here, in 100 mLs. So if we're only going to make 15 mLs, the amount that we would need would be 15 milligrams. And you could do the same for glycerin. All right, so glycerin is 2.5 mLs per every 100 mLs that we make. We're only going to make 15 mLs, so we're going to use 0.375 mLs. This is like saying this recipe is for 100 cookies. We only want to make 15 cookies. What do we do? How do we reduce the formula? This is what we're doing. And then the sterile water, right? Sterile water for injection. This would not be a number we really can calculate. All we can say is that you would QS to 15 mLs. Right? Another way to do that is, you will see in the book, is that you could use, if you don't want to do it outright this way, you can find what's called a factor, basically. In other words, what number you can multiply everything through to get the number immediately. But it's, in my opinion, the same sort of a number of steps. So you would say you want to make 15 mLs out of the 100 mLs. When you divide 15 by 100, you get a factor of 1.5. So you can take these numbers that you see on the left here for the amounts. So I can take 500 milligrams, I can multiply it by that number, which I just got, which was 0.15, and I get 75. And you see that's where I got 75 from here. You do the same thing for the dexamethasone, 100 times that. And the same thing for the glycerin. So you can get this, which is a factor method, right? You can just get a factor. It's just a ratio of the amount you are looking for and the amount that the recipe is. So how much of a reduction that is from the original parts. Anyway, like I said, that you feel comfortable doing, doesn't matter, but the one that comes quickest to your mind and makes most sense to you is the one I would suggest that you go with. Let's look at another one. It says, based on the following compounded formulation, determine the ingredients of each. Needed to prepare 60 grams. This gives us a formula for, we have here coal tar. It's an ingredient that's almost like tar. We have zinc oxide, which is going to be a white powder, and then this is going to be hydrophilic ointment, which is an ointment. So we're going to take these ingredients and we're going to mix them into an ointment and make a medicated ointment with coal tar and zinc. Notice, though, we want to know how much to prepare 60 grams, but all we see here is just parts, and parts. Anytime you see parts, you can really put the unit that you want on it. So I'm going to say I want parts to equal grams. So all I'm going to say is this is grams, this is grams, this is grams. If I wanted them to equal milligrams, I can say a part is a milligram. If I want to say a part is an ml, I can say a part is an ml. It's whatever I really want to do. It's meant to be a ratio, a proportion of each one of those ingredients in a total. So all I'm going to say is that I got 5 grams of coal tar plus 10 grams of zinc oxide plus 50 grams of hydrophilic ointment is going to give me 65 grams total, or 65 parts total, right? So there's 65 grams or 65 parts total. So how much will we need of each? In the coal tar, if I want to rewrite it, I can say I need 5 grams of coal tar every time I'm going to make 65 grams, right? I'm going to call it CT for coal tar. Every time I want to make 65 grams, right, of the total product. If I'm only going to make 60 grams, right, of the total product, what would I actually need to do? So I want to use 5 grams of coal tar. Every time I make 65 grams, I'm only going to make 60 grams. I got that 4.615. So 4, right, a little smaller, 4.615, right? So about 4.62 grams is what I'm going to be utilizing of the coal tar. The next one for the zinc oxide, Same exact thing. This is 10 grams of zinc oxide every time I want to make 65 grams total. I'm going to make 60 grams total. This should be about 9.23 grams. And the same thing for the hydrophilic ointment, right? You're going to do 50 grams of hydrophilic ointment every time you make 65 grams, right? Hydrophilic ointment. And we are going to make 60 grams total of the compound, and that'll give us about 46.154. You can also do the factor method if you wanted to do that, right? The factor method is, again, you can take the total amount that you're looking to make, which is 60 grams, over the formula total amount, which is 65 grams, and you get a ratio or a factor of 0.923. So you'd multiply each one of these numbers by 0.923, and you can get that as well. And again, this is that factor method. Any method you want that you find comfortable, as long as you're getting the right answer in the end. Another example about capsule formulations. This says you have a formula for 7 capsules, right? Calculate the amount needed to do 30 capsules, right? And then it says, what would you label the strength of it? So in other words, all these totaled together is going to be an enough. This is for 7 capsules, right? So each one of those ingredients is mixed together, and then it's divided into 7 capsules, but we want 30. So what we would do is, for the theophylline, we know that we need 826 milligrams, right? Every time we make 7 capsules. Well, we want to make 30 capsules. Our number would be 3,540 milligrams. The ephedrous sulfate, I'll call it, we want 168 milligrams of ephedra every time we make 7 capsules. But we want to make 30 capsules. That number should give us about 720 milligrams. And we have the phenobarb. The phenobarb says we need 56 milligrams every time we want to make 7 capsules. We are going to make 30 capsules. How much do we need? We need about 240 milligrams. And the last ingredient is lactose. This is the diluent or filler. If we want to make these capsules, we mix 112 milligrams per 7 caps times 30 caps, and that's going to give 480 milligrams. Now the question that's also being asked here, and it says, is what would you label the strength of each active ingredient per capsule? So in other words, we'd have to take this 826 milligrams. This is the amount per 7, right, capsules. What is the amount per 1 cap, right? So that's what we would do. We would take the 826 divide that by 7, and we would say 118 milligrams per cap of the theophylline. And we would do the same thing with ephedra. Divide this by 7, divide this by 7, divide that by 7, but we don't list this because it's in an active form. So usually we don't do the inactives. And that's what you would list on your label. The final calculation, the types of calculation that we'll look at here, is going to be calculations that are looking at active drug moieties. So it would be nice for you to read what we mean by that and what we are trying to say when we're doing these sort of conversions. And you will see that formulas will either have the dose of the drug based on the base formula of the drug or a salt of the drug. I think an example here that I will show you is these. So if you look at the label for these drugs, if we look at this first one here, which is ibuprofen, you can see that it says that every tablet here has 800 milligrams of ibuprofen. And you just see the name of the drug, and you also say that each tablet contains 800 milligrams of ibuprofen. Now, sometimes drugs do not really have great solubility, so they don't really get absorbed when taken orally, so we make salts of those drugs. If you look at this next example, it is naltrexone hydrochloride. So here's the drug naltrexone. It is made in a hydrochloride salt. And you'll see that it says each tablet contains naltrexone hydrochloride 50 milligrams. So this is not the amount of milligrams of naltrexone, it's the amount of milligrams of naltrexone hydrochloride. So the drug is based on a dose of the salt, naltrexone hydrochloride. It gets confusing because sometimes we use the salt, but we still base the drug on the active amount only. So for example, this case, it says azithromycin 500 milligram tablets. Notice this little asterisk right here. If you look at the little asterisk, that usually means that the 500 milligrams is not just azithromycin. So if you look over here, is each tablet contains azithromycin monohydrate that's equivalent to 500 milligrams of azithromycin, meaning they put a certain amount of azithromycin monohydrate, the salt, right, or in this case, a hydrated form of it, and when they weighed that amount out, the amount that actually is the azithromycin is only 500 milligrams. Here's one other example. You see atorvastatin calcium, and it says 10 milligrams, and it has the asterisk next to the word. If you look over here, it's going to say each tablet contains atorvastatin calcium equivalent to 10 milligrams of atorvastatin. So even though they actually put the name of the salt here, this amount of milligrams is not the amount of milligrams of atorvastatin calcium, it's the amount of milligrams of just the atorvastatin. So it's confusing sometimes in the wording what we do. So usually drugs have the base, and by base it's not acid base. This means the base compound, the base active. So the base is just the atorvastatin. The salt is the atorvastatin calcium. Right? The base is azithromycin. Right? The chemical that they're using is azithromycin monohydrate. Here, the base is naltrexone. The salt is naltrexone hydrochloride. The base is ibuprofen. There is no salt here. All right. So what we're looking for is ways to convert. How do we know how much active base of the product is, or how much is the salt if we had to measure out in order to compound with? So if you look at an example, here's even one with an inhaler. This is a ProAir inhaler. It says that every pump of that inhaler gives you 108 micrograms of albuterol sulfate, but you only are getting 90 micrograms of the albuterol base, meaning this portion right here is albuterol is 90 micrograms. So if you had to weigh out 90 micrograms of albuterol by using the salt, you would weigh out 108 micrograms on your balance. If you really had a balance going that low. So if you weigh out 108 micrograms, 90 micrograms of that is the active drug. The rest of it is a sulfate salt. So you can do conversions using this, that the drug moiety, so that the amount that's the drug moiety in grams, and the drug compound, right? These are grams per mole. So these are the molecular weights. Grams per mole is the molecular weights, right? So if you take the molecular weight of the drug moiety over the molecular weight of the drug compound, and the drug moiety meaning the drug base, right? And then the other one is the actual salt or the compound, whatever it is, if it's a hydrate or if it's a salt form. So let's look at an example. I think it'll give a little more clarity to this. So this question says, how many milligrams of fluoxetine are in 10 milligrams of fluoxetine hydrochloride? So if I had a bottle of powder, right? I'm going to draw a little bottle, and inside of here is a whole bunch of powder of a drug that I got, right? And if I took some of that out and I put it on my balance, and if I took 10 milligrams of this, and this has a label, and it says it's fluoxetine. This is the hydrochloride salt, and I weighed out 10 milligrams of it. How much of this 10 milligrams is just fluoxetine? So I'm minusing that salt component from it. Well, what do? I'm going to be looking at their molecular weights, right? If you look at their molecular weights, you have the molecular weight for the fluoxetine is 309.18, and the fluoxetine hydrochloride is 345. And that should make sense to you because the fluoxetine is just the base of the drug. The fluoxetine hydrochloride is a salt, so it should weigh more because it's got more things there. And this is just doing a ratio is what we would just do. You're using a ratio of saying that every single time you have 300, right, or I should say this, every time you have, or you're looking for, so 309.18 is the drug, I'm going to call it, right, is fluoxetine. 345.63 is the drug salt in this case, or fluoxetine hydrochloride. So every time you weigh out 345.63, whatever, grams, milligrams, you have 309.18 of the drug. If you're going to weigh out 10 milligrams of this drug salt, right, how much do you get? That's what you're looking at. So in our case, you're going to be seeing that you're going to have about, it's roughly about 8.945 or 8.95 milligrams. So when you weigh out 10 milligrams of this right here, the amount of fluoxetine in that is 8.95 milligrams. That's what's in there, 8.95 milligrams. It's just setting up this ratio. This ratio can be either way. So even though I have it here, right, it's either way as long as you put one and the other, right? You need to know what the drug molecular weight is, and you need to know what the salt molecular weight is. And you can put any units that you want on that, almost like when we did the part. So I can say that 309.18 milligrams, 318.9 grams, whatever. Let's work in the backwards way. This one says how many milligrams of fluoxetine hydrochloride will be needed to compound the following prescription. So here is what's happening. We have the same bottle here, right? So this same bottle of fluoxetine hydrochloride. We're going to make capsules. The capsules have to have 15 milligrams of fluoxetine, the base, the fluoxetine. So the question is, well, how much of this powder do we have to weigh out, right? How much of this powder do I have to weigh out so that I get 15 milligrams of fluoxetine per capsule, and I want to make 20 capsules. So first, let's figure out how much fluoxetine you need. You need 15 milligrams of fluox, right? Actually, I should label this drug to make it a little bit easier. This is how much drug you need per one capsule. We want to make 20 capsules. So we need 300 milligrams of fluoxetine, or the drug, the base, okay? So now how much of the salt, how much of this salt form of the drug, how much salt do we have to weigh out? Well, use the same thing that we know up there. We know the ratios of each one of these. All I'm doing is just solving in the other way. So I can say that every time I weigh out 345.63, right, milligrams, I can use whatever unit I want, of the salt, I get 309.18 milligrams of the base. Where did I get those numbers from? The molecular weights, right? So if this is the amount of milligrams I need to weigh out in order to get this amount of drug, right? How much do I have to weigh out if I want 300 milligrams of the drug, the base? And this should be 335.36. 3677, we're going to say 335.37 milligrams. So notice I would weigh out on my balance right here 335.37, and in that amount of milligrams of the fluoxetine hydrochloride, I would have in it 300 milligrams of fluoxetine itself. All right. So, and you will see here that this little note that I have, the strength of fluoxetine is based on the active drug moiety. So it's based on the base, right? And not the hydrochloride salt. So when you see a prescription and it's 15 milligrams, it means that there's 15 milligrams of the drug, right? Not 15 milligrams of the salt form, all right? But not always the case with other drugs, as you've seen in this example, where this naltrexone is the weight of the actual salt form. All right. So that is it for the calculations that are involved in certain prescriptions for animals, as well as some of the ones that we do for compounding and converting smaller recipes or formulations that are given to you to bigger ones, as well as looking for the active drug compound. All right. So once again, this is Pharmaceutical Calculations, the most important class because it is the only one that counts.